All right, let's take a look at this problem again. So maximum length of a concatenated string with unique characters. Right, you are given an array of strings array, and a string formed by concatenation of subsequence of array that has unique characters. We return the maximum possible length of s. So for this, we will go and search for all answer space, and I will be changing the result here. Let's say that it's 0. What's the in that case it's 0. So I will have this result 0, and I'll just return result 0, and I want to call the search answer space or solution space here, which will be the first search. So I will be passing the array, I'll be passing the index that we are currently in, I'll be passing the current string here, and then also I want to pass the result so that I change it. And here okay, I'm just gonna have these functions in this function of solution. So max length, so I'll be, so DFS, we get array, we have the index, I will say array, I will have it as I, and the current string will be current. I can have it like this, and then result is result. And here, so if we reach at the end of the array, which means that if I is equal to length of array, we just go in this and we want to return. And also we will call our recurse like this. So there's two cases. We include the current, we don't include the current element, and we include the current element. And if we don't include the current element, we will have pass like I plus 1, and the current will be the same. Actually, yeah. And here we will have result, and then DFS array I plus 1 again. But current, I want to add the current, which is array I, and I will have results. So in this way I search the result. So when I return here in the base case, if the we have to check that if our current is unique, every element, every character in current is unique. So if all unique current, I'll just pass current. If all unique current, then result 0 will be equal to what I have. Maybe we have the unique. We'll have this unique here. Oops, like that. And if unique is greater than 0, number of characters, unique characters are greater than 0, then I want to or result at 0. Then I want to do this, right? And I also want to, in this unique function, all unique, or like unique count, or actually, yeah. So I'll take the current, and I'll just go through it, and then I also need a alphabet array, which will be 0 for every I in range 26, and for every I in for every character in current, I want to go over this, and if alpha array c minus a will give us our index is greater than 0 or greater than 1, then we just want to return -1, and we also want to increase that after we go in. We want to add it as a frequency, so here like that, and so it will be +1. And if I at the start they will all 0 when it is 0 or 1 or greater than 1, then we just return that -1. So when we return -1, this won't go in this, but we will return if it is not -1, if it is the number of length of current, because in that case we have it all unique, so we just return the length of current. In that case, it can be greater than the current result, and if it is greater than the current result, we update it. So I think this should work. Let's see. What is this? String and string. So I guess I have to change it to ord minus ord like that, and I also need this here like that. Okay, now it's working. So we just have two cases where we include the current element and where we don't include the current element, and we include the current element. We just go 2 ways, and for instance, like we start with this one, and then we increase I by 1, we include this, or we don't include that. So we will have 2 paths, and every possible way we just try it, and then if the unique path, if the unique all unique, we then update the result if it is if we need to update it. So if it is greater than, if the new unique count is greater than the result. So that's the basic logic of this problem. So we are trying to go over all solution, and we just return the maximum by using this array, result array. And all right, so that was it. What's the complexity? Since we have 2 calls in each, we have 2 to the power of 2, and also times 26, which will be, again, it will be the same. So because we have 26 characters, so it will be, I'm just gonna put it here. So time is of 2 to the power of n, and space is of n, because we only go n times, like the height of that tree is n, because in that case we use all the items in the array. So this is our space and time complexity. So yeah, I'm just gonna submit this with this also. So yeah, anything else I want to add? No, I don't think so. All right, that was it.